All right, today we are pulling back the curtain on one of the first and most fundamental ideas in all of machine learning, linear regression. Now, I know it might sound a little basic, but trust me, this is the perfect place to start. Why? Because it shows you the secret sauce, the fundamental way an AI actually learns from data.
So just think about it. You've got this massive spreadsheet, just a whole mess of data points. To our eyes, it looks like complete chaos, totally random. So how in the world does a computer stare at that and see a pattern? How does it learn to predict what's going to happen next based on what's already happened? Well, believe it or not, the answer starts with something we all did in, middle school math? It all comes down to drawing a single straight line. Yep, that's it. That's the secret. And today we're going to see how that one simple action is really the first baby step toward all of artificial intelligence. Okay, let's get right into it. What problem is this thing actually trying to solve? At its heart, it's pretty simple. It's all about using what we already know to make a really, really good guess about something we don't. In other words, it's all about making predictions. So here's the official, kinda nerdy definition. But let's just focus on the important bits: predict and continuous numerical value. This just means we're not trying to guess a category, like is this a picture of a cat or a dog? Nope. We are trying to predict an actual number, like what's the price of that house going to be, or what will the temperature be tomorrow afternoon.
And you see this pattern everywhere, right? We take one thing we know, an input, like how big a house is, and we use it to predict a number, the output, its price. We take years of experience to predict a salary. It's all about finding the hidden relationship between those two things.
Okay, so that's the what. Now for the how. How do we actually go from that big, messy cloud of data points to a useful prediction? Well, this is where it gets really visual. We're going to see how to turn that chaos into a clean, simple prediction machine. Let's just stick with the house example. It's a great one. I want you to picture a simple graph in your head. Along the bottom, the horizontal axis, you've got the size of the house. And running up the side, the vertical axis, you've got its price. Now, every single house in our data is just one little dot on that graph. You'd probably see this big cloud of dots that kind of trends up and to the right. Got that cloud of dots in your head? Good. Because here's the magic. The computer's entire job, its whole mission, is to look at that cloud and draw one single straight line right through the middle of it. But not just any random line. It has to find the one perfect line that gets as close as possible to all those dots at the same time. We call this the best fit line. And the second that line is drawn, it transforms. It's not just a line on a graph anymore. It's a tool. It's a prediction machine. Now, if you want to guess the price of a new house, all you do is find its size on the bottom, go straight up until you hit the line, and then look over to the side. Boom. There's your prediction. The line has learned the pattern. But wait a second. How does the machine know where to draw that best line? Does it just get lucky? Not at all. It learns. It learns through trial and error. And the real secret behind that learning process is all about measuring its own mistakes. And this brings us to the most important word for this whole process: error. It's super simple. For any dot on our graph, the error is just the vertical distance, the gap between that real data point and the line the machine drew. A huge gap is a big error. A tiny gap is a great prediction. So the machine's goal is to wiggle that line around until the total error for all the points is as small as it can possibly be. And this makes it crystal clear, right? On the left, you've got a bad line. Look how far away the dots are. The errors, those gaps, are massive. But now look at the right. That's a good line. See how it just slices right through the data? The points are all hugging it pretty closely. The total error is super low. That's our winner. So how does it find that winning line? Well, it does this little dance, this learning loop. Step 1, it draws a totally random line, just plops one down. Step 2, it measures the total error and says, oof, okay, how bad am I? Step 3, it makes a tiny little adjustment. Maybe it nudges the angle up a bit. And then step 4, it goes back to step 2 and does it all over again. It repeats this loop, measure, adjust, thousands of times, until it literally can't find any other adjustment that makes the error smaller. And at that moment, it stops. It has learned. Okay, so drawing a line through dots. That's cool. But how does this simple, almost basic idea actually get used in the real world? Well, this is where it gets powerful, because this foundation lets us solve some seriously complex problems.
So what we've been looking at is called simple regression. One input, like a house's size, predicts one output, its price. But what if we know more stuff? What if we know the size and the location and the number of bedrooms? Well, that's called multiple regression. We can't really draw it as a 2D line anymore. Now we're fitting a 3D plane or even a higher dimensional surface through our cloud of data. But the core idea, it's exactly the same. Get as close as possible to all the dots.
And I mean it when I say this is used everywhere. Businesses use it constantly to forecast sales. Wall Street uses it to estimate financial risks. Scientists use it to find trends in their experiments. And maybe most importantly, even the folks building the most advanced complex AI models out there, they almost always start by running a simple linear regression first. It gives them a baseline, a reality check, to see if their fancy new model is actually any better.
And that brings us to what I think is the most important takeaway of all. The reason learning this matters isn't just about predicting things, it's about understanding the fundamental loop of how machines learn, period. Make a guess, measure your error, and then adjust to reduce that error. That core logic, that little loop, is the heartbeat that powers almost all of machine learning.
So I'll just leave you with this final thought. If a machine can learn all of this, if it can find patterns and predict the future just by figuring out where to draw one straight line, just imagine what becomes possible when it can learn to draw curves and planes and incredibly complex shapes in thousands of dimensions. It's pretty amazing to think about, and it all starts right here.